Hello. In this video, we are going to be covering the What Would Python Do question for week 6 of CSM. And yeah, alright, so to begin, uh, we will also be doing box and pointer diagrams, and I will be drawing those out. So yeah, um, we have A being assigned to an array 1, 2, 3, and we return A. This would just give us the array itself, which is 1, 2, 3. And what that would look like is, let's go A being a pointer to 1, 2, 3. And because just to reiterate, or to clarify, this is a pointer just because it is not a primitive value like an integer, boolean, string. Yes, so because it is a list, we do pointers. And yeah, now we have A index 2. Remember that arrays are 0 indexed. So the second index, the element at the second index would be 3. And if we were to go backwards, this is kind of the similar effect where we just number it from -1 to -3. And it could keep going as well. But in this case, since it's only -1, we can only go back one space, and that would also give us 3. So now we have a new variable called b, and we want to assign it to whatever a is, and a is a pointer to this list here, so we just copy that pointer. We then set a to be a plus this new array, or this like nested array, and with this might be a little tricky, but when you concatenate stuff, which is just adding like these sequences slash containers together, concatenation does create a new list using what you have passed in to concatenate. So instead of adding boxes like here, what ends up happening is, let's just say this new thing gets created where it takes A. A is referring to 1, 2, 3, so we're going to have 1, 2, 3. As well as concatenated to 4, and then in this it's going to be a pointer to another list, which is just 5, 6. And that would kind of just look like this. Let me rearrange the arrays. But yes, concatenation does make a new list, and that is why we don't modify the original list that we do have. And yeah. Well, let me just make that clearer, sorry. Nice, okay. That being said, we return error. We put in A that would return this new nested list. 5, 6. Okay, nice. And then after that, we want to return B. B is still pointing to what A was previously before we reassigned it, and again, that would just be 1, 2, 3. Alrighty, now we have this new variable called C. We assign it to whatever A is pointing to. A is pointing to this new list. And we want to reassign A to 4, 5. Because we're just creating a new list and like this isn't any reference to anything or like any pointer, we just make a new pointer to this new 4, 5 list. And similar to like with B, and so with B and C, the reason why these lists don't get lost, is because there's still one pointer referring to it. Otherwise, if there was none, then that would just get lost in memory. Okay. Then we have A being set to 4, 5. We did that, and then we want to return A. This would just give us 4, 5. And then we want to know what C is. C is just the pointer to this list right here. So it would just give us 1, 2, 3, 4, and then 5, 6. Nice. Then after that we have list slicing. we have this new variable called D. You want to slice C, and slicing does create a new copy. It doesn't affect the original list being passed in. So D would just be referring to whatever C is. C is referring to this list again. Let's just number the indices just in case. Yeah, and then how list comprehension, how slicing works is that the first digit here is inclusive of the index and the last one is exclusive, meaning that instead of getting the fifth index, we would just like do -1 and we'd only get the third and fourth indices. And that would be these things. So we have the first one being 3, or yes, no, 3 or 4? 4, it is 4. First element being 4, because it's inclusive. And a tricky thing might be this whole pointer situation. You might be tempted to just go create a copy of the pointer, or create a new pointer that's pointing to like a copy of the 5, 6 list. But what ends up happening is because the element at the fourth index is a pointer, we want to just only copy the pointer instead, and copy the pointer and copy wherever that pointer is pointing to. So visually, that would just look like this. Yes, and it's just only pointing to the 5, 6 list. And with that being said, D would just return 4, 5, 6. Yeah. All right, we're almost done. So we want to access the C's element at index 4, at the fourth index. Yeah, and let's take a look at that first. So C is pointing to this list right here, and at the fourth index is this 5, 6 list. And this list, we want to access the 0th element of that list, and that would just give us 5. To write it out, it's just 0, 1, and then we would just we get 5, but then we want to reassign it to 7. So this gets reassigned to 7. Nice. Oh, whoops! I missed a step. Okay, C3. You want to change whatever element is in the third index to be 9. This would be this element. 9. Okay. Nice. Now we're all in order. Sorry about that. Okay. And so we want to know what D is. And because D is pointing to this list here, it also gets changed to be a list that is 4 and then 7, 6. Okay, cool. And yeah, it's mainly just because it's pointing to the original list and it isn't a copy. And then after that, oh, whoops, I put it in the wrong place. Sorry. Okay. And then we want to change the fourth index of the C list to be 10. And so we would just remove this pointer here and put 10. And still, our D is pointing to the 7, 6 list. And so that doesn't get lost, and it still keeps track of that. And so if you want to access D, it would just be the same, and it would be 4, 7, 6. Cool. And then we want to return C. C is going to be 1, 2, 3, 9, 10. Okay, cool. And that is the end of the problem.